What if I told you that there's a machine so massive that it could overshadow a 5-story building? An engineering marvel that can connect cities, reshape economies, and dig underwater tunnels with ease. Sounds like a sci-fi movie, right? Well, China is turning this into a reality with the 5-story tunnel boring machine. Why is it that China needs a machine almost the size of a 5-story building? And where does it plan to use it? This machine, known by the name Heron-necked Shanhe shield machine, is the largest tunnel boring machine designed in China. Shanhe was designed to build the Jinan-Huanggang Tunnel that links major Chinese urban areas, which are separated by a sprawling waterway. This waterway makes it difficult to streamline trade and transportation between the areas, as there are very limited options available. Travelers have to go through crowded ferries or congested bridges to reach the other side. Even though they provide some sort of connection, these options aren't feasible for growth and trade. China, being a nation known for their innovation and infrastructure, saw this limitation as an opportunity to make an impact. Constructing a bridge between the two areas wasn't a feasible option, so they decided to do something out of the box. They came up with an idea to build a tunnel 177 feet beneath the Yellow River to create an efficient, faster, and reliable route. An underwater tunnel would cut down the travel time significantly, paving the path for economic development in the area. The tunnel would boost trade operations, which will contribute significantly toward the area's development. Underwater tunnels isn't a new concept in the infrastructural world. Countries like England, France, and Japan have already developed their underwater tunnels, and their success is an example of how capable these projects are revolutionizing connectivity. These tunnels significantly cut down the travel time and provide a more smooth and steady route. For China, the Jinan-Huanggang Tunnel isn't just about creating a 5.8-kilometer-long tunnel beneath the Yellow River. It's about being the best. Building an underwater tunnel in such a critical geological area is a challenging task. To ensure durability, the team needs to look out for challenges like high water pressures, potential seismic activity, and soft riverbed sediments. Building a tunnel this long underwater isn't an easy task, which is why it needed an unusual solution. And hence, we saw the development of a new tunnel boring machine with incredibly powerful size and capabilities. It was evident from the start that this tunnel would not only break records, but would also redefine the bounds of contemporary engineering. China hoped to cement its status as a worldwide leader in infrastructure development, while also delivering a breakthrough answer to major transportation issue. This project is a collaboration between two prominent Chinese entities, the China Railway Construction Heavy Industry Corporation, or CRCHI, and the China Railway 14th Bureau Group Corporation, or CR14G. To efficiently build tunnels underwater, this behemoth of a machine was constructed, which is 12 meters tall and weighs around 4,000 tons. The incredible height and size of this TBM clearly indicate China's aim with the project. Shanhe, at its core, operates pretty much like an enormous eatworm which destroys and eats soil and rock on its way to the end. At its front, the machine has a 17.5-meter diameter face with a rotating cutter head, which is equipped with various tools to cut down diverse materials. From tough granite and rocks to soft clay, Shanhe could cut through any matter. As the cutter head moves and cuts down the material, it gathers it and throws it out of the tunnel through a conveyor system. As this happens, the machine then places precast concrete segments to form the tunnel's walls to ensure the tunnel's structural stability. Shanhe is a different beast when it comes to operating in the demanding underwater digging conditions. Such operations are inherently dangerous due to high water pressure, likely floods, and the requirement of exact cuts at great depths. But this TBM has creative pressure control technology, which lets it run safely and effectively in some of the most hostile conditions known. Modern sensors and AI-powered controls enhance its performance even further, enabling real-time changes to guarantee accuracy and lower the risk of errors endangering the structural integrity or tunnel safety. Building a machine the size of a 5-story building has its unique challenges. For starters, Shanhe was built in a special facility where it was assembled in sections. This is because the boring machine has several components which need to fit and function properly to ensure that the machine operates smoothly. Once each section was completed, they were carefully transported to the project site and assembled there. Transporting such massive sections was a critical logistical operation, as many teams had to coordinate to ensure no hindrance occurred. When completely assembled, this massive machine was delicately lowered into an access shaft. This process was quite challenging as well because a team of engineers spent months planning and calculating the weight distribution of Shanhe to make sure the boring machine is accurately and safely installed. Once positioned, the boring machine was ready to begin its operation underwater and break records. This project was set out to break major infrastructural records, and it is surely doing so. To begin with, the Shanhe is one of the largest tunnel boring machines made by China, with an excavation diameter of 17 meters. It is also one of the heaviest tunnel boring machines, weighing around 40,000 metric tons. Shanhe will be constructing the world's biggest underwater highway tunnel in terms of diameter, which when completed will cover a distance of 5.4 kilometers. And last but not least, China has broken the record by completing 2 miles of underwater shielding in just 110 days thanks to this TBM, with it steadily advancing at 16 to 18 meters daily. The tunnel, when completed, would have an impressive 2 levels parallel to each other, with 3 lanes on each level with a max speed of 60 kilometers per hour, making it one of the fastest underwater tunnels in the world. Everything big in life certainly comes with its unique challenges, especially when you're building a 5-story tunnel boring machine. The journey to construct Shanhe and the underwater tunnel in China has some formidable challenges, like unpredictable water currents, extreme underwater pressures, and unusual rock formations which could seriously damage machines. At one point in this project, Shanhe hit a fault line, causing a major setback, leading to weeks of suspension. However, the team behind it didn't let this stop them, as they learned from their mistakes and adapted the machine to fix these problems. The project is also expected to cost a whopping amount of over $80 million, but it is expected to yield much more than that. Each kilometer bored in this project called for a celebration, and when Shanhe reached the tunnel's deepest point, i.e. approximately 40 meters below the water's surface, it became history. Years of planning, teamwork, innovation, and engineering worked in harmony to reach this impressive milestone. Although the construction of this underwater tunnel in China was a wonder of engineering, its consequences for the economy and the environment are as important. Minimizing the project's environmental impact was one of its top goals. Features in the TBM's design helped to limit dirt movement, influencing maritime environments. Strict guidelines were also used to make sure local wildlife was not disturbed by building operations. Over time, the tunnel's more effective transit path should help to lower carbon emissions. Less cars running on crowded bridges or ferries will help to improve the air quality and lower fuel usage in the area. The underwater tunnel in China could turn out to be an economical game changer for the country. As this tunnel would cut down travel time between 2 major economic hubs, it will boost tourism and increase trade efficiency. Many Chinese businesses will have access to new markets, opening opportunities for economic growth. The project has opened thousands of job opportunities during its construction phase, contributing to the economy. This tunnel, when completed, will cement China's reputation as an infrastructural leader in the world. A project involving such complicated and precise construction techniques is a testament towards China's infrastructural prowess. The techniques and technologies used in the development of this tunnel will be an inspiration for other countries. Shanhe's successful operation will pave the way for further innovative projects involving tunnel boring machine technology. As we witness the evolution of robotics, material sciences, and artificial intelligence, these technologies combined with the TBM technology will surely revolutionize a new era of engineering. Advancements in these technologies will make TBMs more capable, adaptable, and efficient. This incredible technology will allow for tunnels under the most challenging areas like mountains or even oceans. At this pace, we'll be closer to having underwater tunnels that would cover not just cities, but entire continents. What are your thoughts on this impressive 5-story tunnel boring machine? Will Shanhe and the new underwater tunnel revolutionize transportation? Or is it another money pit project? Let us know in the comments section below. Also, make sure to like the video and subscribe to the channel for more videos like this.